Hello, everyone. Welcome to the session. This session would highlight the points you need to know to start building mobile apps with React Native and targets the audience trying to take a plunge into cross-platform mobile apps. Quickly, I have divided the whole session into three parts. First, we will talk about the basic concepts, basics of React, React Native, cross-platform development, and then behind the scene, how React Native works. Then we will see some basic features of React Native, and then I'll talk about some pros and cons I could personally feel from my overall learning experience. So before starting, a little bit about me. As already introduced, I'm Anisha, a software engineer at Red Hat's performance and scale engineering team, and I have been involved with creating and maintaining web-based dashboards for performance monitoring tools. Being a React developer over 2 years now, I recently decided to take a plunge into app development with React Native, mostly to explore what all I can learn and achieve through my existing knowledge of React. And that's how it started, and that's what I'm going to share today. So, without any further delay, I'll move forward. So, before getting into React Native, let's start with React. React is a library for building user interface used for web development. But anyway, React as a library is not concerned about what we are making with it, because there is another library, React DOM, that is actually responsible for the web support. So React itself is platform agnostic. It manages state, handles component, manages the data flow, passes the data throughout the components, and all the stuff that happens in React. Now, what is different? What is different in cross-platform? Normally, when we build a native app, we have to build a separate one for Android and then a separate one for iOS or Apple, each using that specific platform language. And unfortunately, the need for separate platform language has some disadvantages. Like, to get started, I don't know both of the languages, so yeah, it's difficult to program mobile native mobile apps, like, because it will require high levels of skills in 2 to 3 different languages, and then expenses of creating and maintaining an app for each operating system is much more expensive, because each platform has its own user interface, standardized widgets, and features. Apps will not be uniform from platform to platform, and that would create a very bad user experience. And because it will be different depending on the device. And as we know, nowadays, many people have more than one type of device. So when they are using the app on iOS and switch over to Android, their experience will be different. Now, cross-platform development provides the flexibility to build your app using a universal language like JavaScript, which can be exported to various smartphone platforms. This allows one app to work across multiple habitats. This can be done in two ways. So there are two different ways. First is creating native apps, like to with tools using React Native or Xamarin or Native Script. You end up with an app that still uses native APIs, which allows for excellent performance across all platforms, and without having to code each separately. And this result in very nice app that runs well and is a great compromise over time and expenses of building a native app. Now, talking about hybrid app development is a tier lower than native cross-platform development. It relies on a built-in web browser and HTML or CSS and JavaScript to render the app. The platform is coded and then rendered on the smartphone inside an app container, which is again driven by an internal web browser. In hybrid apps, developers program using native app web languages, but wrap it in a native wrapper for each operating system, thus I guess thus rendering it usable across multiple platforms. Now this can work, but this might have some major performance issue for complex apps. So there are several advantages to using cross-platform development, like the expenses are reduced as the need to code in two or three separate languages it doesn't is not required anymore, and the uniformity while talking about user experience increases between different platforms or two different operating system, creating a more seamless user experience. Now, the development tools are like familiar as they employ common programming languages, and it is ideal for prototyping also because it allows faster time to market on more than like in other platforms. So cross-platform apps can actually help us achieve quicker deployment and adoption at a lower cost, uh, since we have got this native languages like React Native, so native frameworks like React Native, and there are several advantages. There are some disadvantages to using the cross-platform development as well. Like programs can be less efficient, and this occurs due to lack of hardware power to perform smooth HTML5 animation on like low to mid-range devices, and the program itself may need to be more generalized and in the process becomes less sophisticated than it would have been if it would have been built with for a specific program, like, right. And using advanced features with cross-platform development may take more battery power and a lot more resources than with a native application. Now, React Native, on the other hand, is a separate library with a collection of separate special components to use in the React Native app. Now, it is different that React Native knows how to compile the components to native widgets for Android or iOS. So it's kind of like React DOM library. React Native provides access to native platform APIs like map or camera or notifications. So basically, it connects the JavaScript code with native platform code. Now, something noteworthy is we can also write native code and connect it to JavaScript, but not sure how much effort it's going to take in case of a fully functional complex system, as I have not tried them yet. Also, there is React Native for web, which intends to let us write single app that runs in a browser using standard web technologies, or an iOS or Android as a real native mobile app. We have a different package React Native Web for it, and it requires minor configuration, which all are available in React Native documentation itself and pretty simple to follow. Now, even in my call for paper, it was mentioned that write JS code once and run it everywhere. Well, I found out React Native fairly easy by using some like some third-party library about which we are going to talk in a couple of minutes. But if you want to build the app from scratch with a bare bone structure, it's kind of a hard work. And when they say write JavaScript code and run it everywhere, but I found a very nice tagline in a tutorial which said learn once and write it everywhere, because we definitely need to adjust the code base so that to make it feel or like look better in different platform and screen sizes. Now, why React Native? Building native mobile apps is one thing, which is React Native allows us to write native apps in JavaScript or both iOS and Android. It gives us ability to use all the native components like gestures, push notifications, camera, location, and there are some other JavaScript libraries for building mobile apps like Ionic and PhoneGap, but those libraries are WebView, and apps built with those technologies are not native. Now, yeah, with React Native, we can build mobile apps that can run on iOS and Android, and this is one of the great benefit of React Native. But before it was created, we had to build our app twice and with different codes, like one for iOS and using Swift or Objective C, and one for Android using Java or Kotlin. And React Native solves this problem, so you can build your React Native app and it will work in iOS and Android out of the box, which is pretty awesome. And while we are building React Native apps, we will actually write JavaScript, React.js code, which has pretty much almost similar structure as in terms of the syntax. So it allows us to build great UI and user experience components in a very fast and efficient manner. If we are well, provided you are already familiar with React and JavaScript basics. So when I started learning React Native, I saw so many similarities between React and React Native code. So the question which continuously was ringing on my head in my head is there any specific notable difference apart from the platform compatibility? And I found out a couple of them. Uh, that is, React can be described as a base derivative of React DOM for the web platform, while React Native is a base derivative in itself, which means that the syntax and workflow remain the same, but the components alter. How that we are going to talk in after a couple of slides. Now, React eventually is a JavaScript library which enables the programmer to create an engaging and high performing UI layer, while React Native is an entire framework for building cross platform apps, be it web, iOS, or Android. Now, in React.js, Virtual DOM is used to render browser code in React.js, while in React Native APIs are used to render components in mobile. The apps developed by React renders HTML in UI, while React Native uses JSX for rendering UI, which is nothing but JavaScript. The next thing is CSS is used for creating styling in React.js, and being a front-end designer, like it is the most important thing to make sure to be available. And while working on React Native, it uses style sheet for styling, which is not really CSS but JavaScript. It's a subset of CSS, we can say. And in React, the animations is possible using CSS, just like web development while we are writing web dev code. But in React Native, we use animated API, which is used for including animations across the different components of the React Native application. So overall, it basically depends on the use case. If the need is to build a high performing dynamic and responsive UI for web interfaces, then React.js is best option. While if the need is to give uh, the mobile apps a truly native feeling, then React Native is the go-to option, I would say. Now, with both React and React Native, we create normal React component with JavaScript. But in React Native, we use special components, and let's see how. So we build React components uh, uh, we built React Native components with special components, and we can't use HTML and divisions over there because those are not supported in React Native. So the special components for React Native are compiled to make React Native apps. In the example, you can see, whereas in React code we write divisions and key tag or header tags, here we are using view and text, which are like special components that are going to be used in React Native. So even though React Native tags look almost like HTML tags, but of course these are special components compiled to native components. It maps reusable components to the respective platform equivalent. Now it's important to note that the views are compiled, uh, the view as in the things that we see, but not the JavaScript logic code, which in matter of time boosts performance. So now, as discussed in the earlier slide, it is important to mention that for UI, React Native gives special components which gets compiled to native view. And for our logic, like for Redux or HTTP request or transferring data, the transforming data, the JavaScript code isn't, whatever JavaScript code we write, that isn't compiled, but instead it runs in a special thread hosted by the React Native app itself. It's like a mini JavaScript app running inside the React Native app and hosted and run by the React Native app itself. And our JavaScript code then can talk to the native platform. So we can picture it like this. For example, this is your code, and this is the native platform where you want to run your code. In your code, you have your view inside the view tags where we write things that we want to see in the screen as a pictorial view. And then behind it, we have our JavaScript code with all the logic for all the functions. Now what happens is the view gets compiled to a native view, and the JavaScript code remains separate, and sorry, pardon me for the mistake. It runs in a separate separate thread, and then it forms a bridge with the native platform or modules, and then the JavaScript code can talk to the native modules like your camera or notification, etc. Sorry, the native platform modules over here should be the separate thread. Pardon me for the mistake. So that's how the flow works in React Native. Now, JavaScript and React knowledge is mandatory for React Native app development. But apart from that, we have specific hardware requirement. For example, if you want to make iOS app in Windows, you have to do it with third-party library Expo remotely. And in Windows, so we have full support for Android development, and for Mac OS, we have full support for both iOS and Android. Now, to get started with React Native development, we have two ways. We can use a third-party service called Expo, and Expo is a third-party service with managed app development structure. So the data flow is managed over there. We will talk about the workflow later in the slide, and it provides utility features and sets everything up for us. But it limits it limits the code to like Expo ecosystem, which kind of a turn off for many developers, but I feel like it's fair enough for beginners to get started with. And then we have React Native CLI, which is managed by React Native community and is almost bare bone development with a basic setup. Now, even with full control and flexibility, the setup process is a bit complex. But the good thing is we can always switch between the two. Expo never locks you in. You can eject anytime, and your project will just be a typical native project with the React Native and Expo SDK. packages, and that your app is the SDK packages that your app is using install and configure. Now there are a few steps after to get the environment ready. Like first and foremost, I guess everybody will know this. We need to download Node.js to use everything in the JavaScript ecosystem, including Expo and React Native. And then we need to get command line tool, which will package, serve, and publish the project. And we can simply run npm install Expo CLI, and we can install it globally. Uh, and then we can create the project with Expo init, the project name, and get into the project and start the app by Expo start. Now to preview, there are a couple of ways, but with Expo we get a separate Android app, iOS app for Expo client, which we can install in uh, our real device. And once you run Expo start, it actually opens up a tab in your browser, and you can see a QR code over there in the Expo client app. You can simply scan the QR and you can simulate in your real device. So as I said, to see what changes are happening, we can use the native real devices, which is using real devices by downloading Expo client. And Expo is a developer tool for creating experiences with interactive gestures and graphics using JavaScript and React Native. And we can use Android Studio once you're done with the setup, like done with the SDK setup, and then we can run the emulator or simulator, which is where we have to run and test our app. And we can do that in, like, there are different choices for different SDKs. We can, though I haven't tried it out, but I saw an option of using Genymotion. It's a desktop application that provides a virtual simulator to test the application. And if you're interested, you should definitely check it out, because I still have to do that. And next, for iOS, Xcode has nice emulators that you can use to test your React Native app. And at the end, we can publish the Expo app, or we can publish a standalone app, whatever is convenient for you. Now, talking about the basics of React Native, there are different core components in React Native. Uh, Sorry, there are different core components in React Native, like uh, view, text, button, or text input. There are custom components, which we can make by mixing the core components. We create these by creating a class which extends React component, which this method should be used. Uh, this method should be used if we need lifecycle methods, by writing a function which returns a view for simpler syntax. Um, Pardon me for the lorem ipsum, I kind of missed it. I'll just explain the headers. Talking about style, it doesn't use HTML or CSS, it uses JavaScript. It is based on CSS syntax, but only a subset of properties and features. And we can use CSS in inline or style sheet object. And if you are getting into React Native, then I highly recommend using Flexbox, which is really helpful for uh, which is very helpful for making responsive app. Now, we can also store default style constants to not have to repeat the value. Clearly, there is much more to play around with CSS. For navigation, React Native uses a package called React Native Stack, and it becomes fairly easy way to navigate between the components in that way. And we can also use component state for managing state or Redux, etc. Now, there are also different native device features like camera roll, which is a React Native module that provides access to the local camera role or photo library. And there is geolocation, as the name suggests, it's used to access the geolocation of the phone. There are React Native Camera. It's a camera component for React Native, and it also supports barcode scanning. And React Native Fast Image, which alternative for slow inbuilt image components, and a bunch of other things like maps and gesture handle and etc. Excuse me. Uh, So as I said that to maintain responsiveness throughout the app, it's a really good way to use Flexbox, which I prefer. But I also found another way to get like paired pixel density of width and height, and uh, the time pixel ratio and dimension, and then calculate the orientation, get dimensions and pixel ratio, and then call the function from style and use event listener to whenever you change the orientation, it can the style can fit into your uh, uh, style can change according to your orientation. Well, I haven't really tried the second method because I prefer Flexbox completely, but yet it's interesting to play around with the modules that React Native provides. Now, an important thing about the whole app development is debugging. And when we talk about debugging, the first question should come is what to debug. And that it is the if there are any error messages to get started, and that means that your app has crashed because of probably syntax error or bugs or value error or failing network requests. And then logical error, like your app will behave unexpectedly, or your app you will get to know any unexpected or any unhandled behavior in your code, or the sequence of use leading to some error that we haven't thought of. And then styling or layout issue, which is directly um, directly affects the responsiveness and user experience. Now, how to debug these? First thing to get started is read the error message, and Google really helps. So definitely read the error message. Most of the cases, the error messages shows us uh, uh, how exactly to debug it. So, and the next thing is, I guess many people don't prefer it, but logging the value with console log, and to track the flow and where it went wrong. And then to debug JavaScript remotely with Chrome Debugger by setting breakpoints. React Native gives us the option to use Chrome DevTools to see the logs of our app, to debug with Chrome, and enable debugging mode in our emulator, or we can simply press Control M, then choose debug JS remotely, and that opens up a tab in Google Chrome with this address, and then we can simply access the Chrome DevTools. And then next is we get a perf monitor, which gives us the user interface FPS, frames dropped, and we need to keep in mind that this monitoring is in development mode, and we can't rely on in the production ready app, and but still we can spot memory leak, etc., using the perf monitor. And then there is toggle inspector, where we can click on items to see the positioning, margin, padding, etc. And we can debug the layout. And I kind of love this one. Now, a better one is React Native Debugger. React Native Debugger is a great tool to debug React Native code. It's a desktop application that gives you many advantages. Uh, it comes with the Redux DevTools and React DevTools integration. You can debug the style as well over here, and it's actually the best debugger for React Native, and it's the one that most of the developers use. Usually, it's available in Mac OS, Windows, and Linux. Now, there are two different types of workflow in React Native. Uh, First is the managed workflow. It is kind of like Rails or Create React app to relate more of which we use for React. And the Expo tries to manage. The Expo uses this kind of workflow, and it tries to manage as much of for the complexity of building apps for you as it can, and which is why we call it a managed workflow. And in the bare workflow, in the bare workflow, along with the developer has the complete control along with the complexity that comes with that. You can use most APIs in Expo SDK, but the build service and easy configuration with app.json, and with app.json, you can refer to tutorials and guides that are oriented towards native iOS uh, and Android app and React Native for alternatives. Now, if like I was confused which workflow is better for me when I went through this, and really, if you are new to mobile development or new to development in general, it is recommended that you use managed workflow. There is huge amount of complexity that comes along with native development toolchain, and the managed workflow allows us to deal with that complexity only when absolutely necessary. And if you are more experienced, then it also doesn't hurt to start every new project their with managed workflow. But we can also eject it whenever we need. So in summary, use the bare workflow when you need it due to limitation. Otherwise, use the managed workflow, and you must likely want to start with the managed workflow. Now about publishing, I haven't really done it manually like myself ever, because I haven't created a full-fledged app yet. But talking about how to do it, I can give a brief overview. Like Android requires that all apps should be digitally signed with a certificate before they can be installed. So if you want to distribute your Android application via Play Store, it needs to be signed with a release key that then needs to be used for all future updates. So before your application binary is uploaded to Google Play, it needs to be signed with an upload key. Signing your application page on Android developer documentation as it describes, and you have to fill in the details. The guide covers the process in brief, as well as a list of steps by step required to package the JavaScript bundle. So it's a good idea to go through the Android developers documentation if you want to publish your app. And for iOS, the publishing process is same as any other native iOS app, with some additional consideration to take into account, which is available in React Native documentation. Uh, the steps would be like to enable app transport security, configuring release scheme, and build app for release. Now, now on web, this is not even an issue. Or when we say that we want to go back, it's easy. We press the back button and the app reloads, etc. But in React Native, it's different. On iOS, going back each screen is being handled by a button or a swiping on screen. And you might think that hiding a back button would prevent the user from going back, but think again. You must wrap your head around it in order to prevent or allow going back. And on Android, there are two ways actually: the button on the app and the button on the phone. Nowadays, we get gestures also. So the magic here is that the Android back button works differently on some devices, and it is either handled by the state of the phone differently, or even it can be killed in the app's process manager. So that's the difference between the going back option in both web and React Native. Now, talking about the navigation on web, React uses React Router, and it when you update the address with a new URL, the React Router listens to that change and it cross-reference the URL with a route and component. On native, you start from the first screen defined in the tech, and and when you go back, this goes off the top of the deck as well, and this means that the first screen is loaded and in the background until you dismiss the stack or go back. So it's a stack functionality. Now,
So,
more
Lisa, sorry for interrupting a bit. It was really interesting, and I think all of us, a lot of people would watch you more and more. But we also promised a Q&A session after your speech, and after like for some minutes. If you don't mind, we can start it now, or you may finish some of your speeches, some of your slides. But I would like to maybe start the Q&A session. How do you feel about that?
Yeah, sure. I can just quickly show those next two slides. There are only two slides left. So those are just pros and cons listed. So I'll just quickly show it.
I hope our audience is okay with that, because yeah, we will be in time. We will try to be in time.
Yeah, I'm so sorry for the delay.
It's okay. It's really interesting.
Yeah, so there are a couple of cons that I saw while trying out React Native and getting grasp on it. So I can take a screenshot of it. It's really straightforward, and then there are obviously there are a couple of points for which I would prefer React Native, and more the foremost thing would be like it's easy to learn being a React developer already. So yeah, that's it. Thanks a lot for the session. Just a closing thing is it is easier to always have in mind that we are building native apps with the help of React Native, and we are not really writing React Native, we are making native apps. So yeah, with that, thanks a lot, and feel free to connect with me for any further query.
Cool. Thank you very much. It was really, really interesting. And yeah, I see that some of the people, they say that they want to hear you even more. We have like some time to answer the questions. Let me just introduce them. Yeah. How difficult is to create custom plugins in React Native?
Well, I haven't tried making custom plugins in React Native, but if we will talk about creating custom components, I guess that would be, if you are already familiar with React, I see that the syntax and the workflow are very similar. So I don't think that would be very difficult for you to create.
Okay, we don't see you, but I think, yeah. The next question is from the same person. He's so active about your speech. Major drawback of React that you observed as a programmer?
Okay, just I forgot to switch on camera. Sorry. Yeah, so working with React, one thing that I become very upset with when creating dashboards is server-side rendering, and then next is getting confused between when to use class component and when to use hooks, because when it's very that's the decision we have to make when we are creating things like how the data is going to flow, and yeah, and the component based approach sometimes create an issue, but it's fair enough. I think the worst one would be the server side rendering.
Cool, cool, cool. Well, Anisha, thank you very much. It was really, really interesting. Oh, I think we have one more question. Just one more question, and that's enough. How much JavaScript do I need to know to learn React Native?
Okay, I would say you need to know basic JavaScript skills to even start learning React or React Native, like the concept of maybe closures or like similar concept. You need to know to you might not see it out in front, even if you are coding already, you might not know those concepts that you are using these, but these are the concepts that you should be familiar with. But learning JavaScript is not equals to learning React. If you know React Native becomes fairly easier. And if you like, you can start using React Native after learning JavaScript, or you can start with React. I guess it will be vice versa. I mean, it doesn't matter if you learn React first or React Native first, but JavaScript base is really important.
Cool. I hope we replied to all of the questions. I think like we don't have any of them in the chat. That was super, super interesting. We would like to have you more for several hours, and I think our audience also. Thank you a lot. See you next time at all our next events. And yeah, thank you.
Thanks, Kevin. Thanks, everyone. Have a nice day or night, whichever time then you are. Thank you.
Thank you.